I would like to welcome you all to tonight's event, How Can Research Protect Spotted Turtles in the Blue Hills? I'm Julia Milo, a Friend of the Blue Hills volunteer. The Friends of the Blue Hills is devoted to protecting and preserving the Blue Hills Reservation's natural beauty, diverse natural habitats, and many recreational opportunities. The Friends organizes hundreds of volunteers each year to help care for the forests, and tonight we're thrilled that Brian Windmiller and John Burkholtz from Zoo New England will be explaining what they've learned from researching one of the species in the Blue Hills that benefits from the Blue Hills habitats. This is the first of two presentations this winter on research in the Blue Hills. The February presentation will be on the essential role that moths play in the Blue Hills, based on research of Tia Kesting-Handley of UMass Boston. So save the date, Thursday, February 17th at 5:30 p.m. We'll put a link in the chat with some more information. Before I introduce the speakers, I'd just like to make a few housekeeping notes. Please keep yourself on mute. If you have any questions during the presentation, feel free to put them in the chat at any time. John and Brian will answer questions at the end of the presentation. And now I'm thrilled to announce our presenters, John Burkholtz and Brian Windmiller. So John is a senior field conservationist at Zoo New England's Field Conservation Department. Since 1992, John has been in the animal care field, working as a keeper and senior keeper at Zoo New England and the Wildlife Conservation Society in New York City. Since 2006, he has assisted Dr. Brian Windmiller with the Great Meadows Blandings Monitoring Turtle Project. In 2017, John transferred over to the new Field Conservation Department as a field conservationist working on rare turtle and amphibian monitoring projects in the Boston region and assists with the He Starting program for zoo and at schools. Brian Windmiller is the director of field conservation at Zoo New England, where he oversees the zoo's local wildlife conservation programs and its support of international conservation efforts. Brian earned his PhD in biology and a master's degree in environmental policy, both from Tufts University, and he has worked in various roles as a conservation biologist since 1987, specializing in the restoration of rare turtle, frog, and salamander species in Massachusetts. Brian is an adjunct professor at the Tufts University School of Veterinary Medicine and has taught at several Massachusetts universities. Thank you, Brian and John. Are you ready to start?
Got it?
Yes, yep.
So, right, I'll start, and I'm going to give I'll be fairly brief. I just want to give you all a quick introduction to Zoo New England's field conservation efforts, because it may well be different than the role that a lot of people expect zoos to play. And then John is the primary presenter, and he's going to talk about the spotted turtle work that we do in and around the Blue Hills. John, can you have the next slide, please? So here's a photo of John and I and one of our colleagues in a wildflower-rich field that we've worked to restore out in Metro West. And I show this picture simply because it's characteristic of what we as a department do. We're currently a 6-person year-round department. We're soon to add a person. And we hardly ever go to the two zoos, the Franklin Park Zoo and the Stone Zoo, that Zoo New England runs. We have little to do with the captive animals on display at the zoo. Instead, our small field conservation department is really emblematic of the work that Zoo New England and many other zoos do to forward the cause of wildlife conservation around the zoos where we all are and around the world. Next slide, please. So zoos have been around for at least several centuries and more or less their current idiom. In the 18th century in France, Louis XIV started essentially a zoo display of captive animals from around the world that was open to at least the aristocratic public. And still in the minds of many, we often see zoos as primarily being places where captive animals from around the world are on display to come and see. But zoos have increasingly, in recent decades in particular, become really important institutions of wildlife conservation around the world. And there's a fair history to that. The guy on the left, William Hornady, was president of the Bronx Zoo, where John used to work, as was mentioned in his bio. And Hornady, who was a buddy of Teddy Roosevelt's, realized early on that American bison, which had once numbered upwards of 60 million individuals in North America, by the end of the 19th century, were rapidly on their way to extinction. Around 1889, they only numbered about 540 individuals in the wild. And Hornady realized that his zoo, the Bronx Zoo, actually could play an important role. So Hornady got bison brought over to the Bronx Zoo by 1905, started a captive breeding program, and bison that were bred at the Bronx Zoo, like here, were then shipped back out west, where they helped form the nucleus of several wild populations that exist and are growing today. Next slide, please. And since that time, around the world, zoos have played a major role in preventing the extinction and in restoring populations in the wild of a bunch of rare species. Clockwise from the left, our largest North American bird, the California condor, numbered only 28 individuals in the early 1980s, when all of them were captured, taken into captivity, originally at the San Diego Zoo. It took years for zoo folks and biologists to figure out how to sustain the birds in captivity, how to breed them in captivity, and how to raise their young in a way that would allow them to do well if they were released into the wild. There were problems all along the way, but with a lot of persistence, they were solved. And today there are over 400 wild flying California condors, whose range is expanding from Baja California almost up to Oregon and east into Arizona. Similarly, Przewalski's horse in Mongolia, the Panamanian golden frog, or another two species that were completely extinct in the wild. The horse, Przewalski's horse, has been successfully restored or reintroduced into areas in Mongolia. Our zoo is one of a number of zoos that is working to help figure out how to repopulate areas in Panama with the golden frog, which is extinct in the wild. They only exist in zoos and other captive collections. Similar story is true on bottom right of the Jamaican iguana, and bottom left, these little snails are Partula snails. There were 11 species of Partula snails on the island of Tahiti alone that are extinct in the wild and are currently only preserved in zoos, but there have been successful reintroduction programs for a few of the species. And in the middle is a plant that our Zoo New England is helping with. It's called the Erubia. It's a very rare relative of our garden tomato. It occurs only in Puerto Rico. And we help support a reintroduction project that a botanist from Eastern Connecticut State University is working on. You have the next slide. So Zoo New England, more like 246 total member zoos, are certified or accredited by an organization, the Association of Zoos and Aquariums, AZA. And AZA has been an effective umbrella organization to really push zoos to devoting more and more of the money that they make into field conservation. And collectively, the AZA member zoos, most of them in North America, spend more money on conservation than any single conservation nonprofit. So zoos collectively have become a big force for conservation. Next slide. But at Zoo New England, we take a somewhat different spin. I think it's fair to say that conservation work that most zoos support is primarily in line with their captive collections. And most zoos, at least in North America, not all, but most, primarily display species that live in areas far from where the zoos themselves are located. And often the conservation programs are primarily towards the benefit of species that live far away. What we do in Zoo New England's Field Conservation Department is primarily work on species right near where we are in Eastern Massachusetts, Southern New Hampshire to some extent. And some of this slide displays some of the rare species that we're currently working to restore. From top left, Blanding's turtles, marbled salamanders. This population of that, the rarest salamander in New England, in the Blue Hills, wood turtles, box turtles, eastern spadefoot toads, left center, and then left bottom. We're currently working on several species, working to help conserve several rare species of butterflies and moths, including this frosted elfin. The three-spined stickleback, there's a population right near Franklin Park Zoo in Boston and Olmsted Park. The only fully freshwater population of this species in New England lives in a tiny pond in the middle of Boston, right near the Muddy River. And we're working towards their conservation together with PCR. And bottom right is the New England blazing star, a rare wildflower that we're helping reintroduce both for its own sake, the species that was once common in eastern Massachusetts and now is for the most part gone from the area. We've started reintroducing them at 5 different sites in the Metro West, but it's also an important species for many insect pollinators. Monarch butterflies, for example, find the nectar from blazing stars an important source of energy when they start migrating back down south towards Mexico in the late summer and fall. Can I have the next slide, John? So we spend most of our time outdoors, and we work in a very hands-on manner here in our area. All of our projects are designed to not only monitor the status of rare species, but wherever we can, to take actions that help restore populations, to increase their numbers over time, if we can, or to reintroduce them to places where they once were. Here, Squiggles and I are collecting marbled salamander larvae from Western Massachusetts. We raise the larvae indoors. We actually do this both at one of our zoos at the Stone Zoo with John's help, but also at several area high schools. We raise them until they metamorphose into small salamanders. And then we release them into Middlesex Fells. Middlesex Fells had a population of marbled salamanders up until the 1930s. They were gone for more than 80 years, and we started reintroducing them about 6 years ago. Can I have the next slide, please, John? So I'll just a few quick examples. John will give you a lot of detail about spotted turtles, but here's one of our interns who now works with U.S. Fish and Wildlife Service, Regina Peters, with a canoe full of buttonbush, a native aquatic shrub. We grew the buttonbush from seed for a couple of years, and we are working with U.S. Fish and Wildlife Service to help increase the coverage of this native shrub in Great Meadows National Wildlife Refuge in Concord, because it benefits and helps aid the survival of young juvenile Blanding's turtles by giving them effective cover from predators. Next slide. And here to follow up in the boat theme is Ryan here is holding a wood turtle that he caught along the Charles River. We started working with Mass Wildlife and with a couple of private partners on this to survey what is turning out to be perhaps the largest wood turtle population in the eastern part of Massachusetts. And we're trying to figure out not only how big the population is, the habitats they use, their distribution, but also how we can help them in things like the creation of nesting habitat. Have the next slide. And here, many of us, John in the foreground on the left, we're planting New England blazing stars at a reintroduction site in Dunstable. This is a site that together with the town of Dunstable, we've been managing. We created this clearing with help, specifically to benefit box turtles, which occur at this site. It's the northernmost known population of box turtles now, and also a rare bird, the eastern whippoorwill. And here we're planting a rare plant that will benefit insect pollinators as well. You have the next slide. And then finally, our field conservation department, working together with other staff at Zoo New England, we also work on a fair number of international projects to which we bring the same kind of hands-on restoration-focused attention. And we use both the funds that we can generate, as well as in some cases, work that our staff can do abroad, but mostly in support of partner organizations around the world that are working in similar ways to what we do here in Massachusetts to help protect rare species around the world, including cross-river gorillas, the rarest gorilla subspecies in the world in Nigeria. I mentioned Panamanian golden frogs. We work with Snow Leopard Trust in a really innovative community centered conservation program in the Gobi Desert of Mongolia. We work with the Barrett's Tapir Survival Alliance that does education programs and outreach to help incentivize farmers to protect Barrett's tapirs in Costa Rica and elsewhere in Central America. We have a new project helping in southern Madagascar and helping work to foster innovative approaches to health insurance and improving healthcare for people who live around a national park that will allow them to thrive better and thus have less need to, for example, deforest the national park, which will benefit not only them, but also the lemurs that live there. We've helped support a reintroduction program for Nubian giraffes in Nigeria. One of John and my colleagues, Emily Wilder and I, will be leaving for Belize in a month to work with a fantastic organization there that is working to reintroduce the rarest turtle in the Americas, the Hicatee, they're called in Belize, or Central American river turtle. And we are trying to figure out, through lots of political difficulties, not aided by the pandemic, how to help work with a group from the UK and from Cuba to help find out about one of the most unique and rare mammals in the world, a cutie that really reminds me of the rodents of unusual size in the Princess Bride movie, the Cuban Salamander. And with that, that's my introduction. I want to turn it over to my colleague, John Burkholtz, with whom I've had the pleasure of working on a variety of conservation projects, mostly focused on turtles, but on many other things since like 2006. It's all yours.
Oh, thank you very much, Brian. So you folks are probably very familiar with this trail map of Blue Hills, and certainly Blue Hills is a beautiful, unique treasure in the Boston area. In fact, I used to live near there and go hiking quite often, so I'm quite familiar with the Blue Hills. Certainly, it really is a treasure in this region, and as you noticed, it entails not only the uplands, the hills themselves, but a lot of lowland, wetland habitats as well. And there's many unique species that are found in these wetlands, and also throughout even the 128 belt. I think they call it the hills outside the Boston Bowl, places like Middlesex Fells and Lynn Woods and Breakhawk Reservation, going west towards Prospect Hill and down towards Cutler Park and Stony Brook, and all those reservations that are run by DCR really are quite little treasures in such a densely populated, one of the most densely populated regions per square mile in the country. So the fact that we're able to find rare species or species that may not be rare globally, but are rare because they're in such a confined space makes this area unique. So we started out actually back in 2017 trying to see if there is still any Blanding's turtles left in the Blue Hills region. Tom Palmer, which probably many folks know, has done a great amount of work, natural history work in the Blue Hills, and he had taken photographs of Blanding's turtles, just a couple of individuals in the past, and the state was aware of it. You could see that notice back in the 1990s, and so there was a neighborhood association that Brian was contacted by to do surveys to see if there were any Blanding's turtles in the Canton Milton area. And we did quite a bit of trapping, surveying in the late spring, early summer months, and didn't find any. And so after trying what looked to be really good habitat for Blanding's turtles, we didn't find any. It doesn't mean they're not there. There still could be a few individuals remaining there because there's just so many wetlands to survey that it's just impossible to, survey every area. And even if there's times we've set traps in wetlands to trap for Blanding's turtles and didn't catch anything, and then other times you catch them. So, but likely there's not really a sustainable or significant population in any way. However, with regards to spotted turtles, although our focus was not on spotted turtles in 2017, we did catch them incidentally in our traps, which we'll explain in a few minutes. And we did find some individuals in some nice habitat that would also contain Blanding's turtles. And oftentimes Blanding's and spotted turtles will use the same habitat. So it's not unusual. So just briefly, spotted turtles are globally listed by ICUN as red list as endangered. They're no longer listed in Massachusetts because more of them had been found in the past, in more recent years, but it's still a species of conservation concern. It's a species the state is still very interested in. Still in many states, they are state listed, such as in New Hampshire, Maine, and Vermont. They're threatened or endangered. Special concern in other states. And there's also, unfortunately, especially as you get with even larger populations further south, is a serious issue with poaching, because these are very cute turtles and people love to have them for pets, or they get into the illegal pet trade. And that's a big concern. So that's why we're a little cautious about giving out where we find these guys, just because the state wants to keep things kind of undercover, so to speak. But what we found, and we'll discuss it more, is that there is a nice secure population in this region. So the adult size, typically they're one of our smallest turtles, about 45 inches in length. Maturity about 10 years. Some literature might list them a little earlier than that, but they're probably more on the later side, being up north. The turtles tend to mature a little bit slower up north here. They can certainly live a long time. We are pretty confident many of our turtles are well over 30 years old, perhaps over 40. We've actually been tracking Blanding's turtles that are likely 70 years or older. So these guys live, very long time. Clutch sizes are small, unlike maybe sea turtles where you see hundreds of eggs, or even snapping turtles, you might see dozens of eggs. Here it's just one to 8, and that's 8's kind of on the high end. Typically it's like 3 to 5 eggs is average. And again, their range is from very southern part of Maine to northern Florida out to Illinois. And they're kind of a coastal species, so they're not found in the higher elevations of the Berkshires. So they're mostly in the Connecticut River Valley, maybe lesser abundance in northern Worcester or Worcester County, but they tend to be more common the further south and east you go, especially southeastern Massachusetts seems to have the highest numbers. And the habitat, they really live in these beautiful little wetlands. You can say it's a natural water garden, and they really prefer shallow marshes, vernal pools, lots of vegetation, lots of shrubs. Brian mentioned about the buttonbush planting, and in this photograph there is some buttonbush growing, big patches in the background there. And so spotted turtles also utilize buttonbush and other wetland shrubs as part of their microhabitat. A lot of tussock sedge and sphagnum areas they really like. But they also, surprisingly, despite being quite aquatic, they will use uplands, such as this area. During the summer, wetlands will dry up often, and They'll go up into the forested areas. They'll also go up to forested clearings to lay eggs as well, as we'll kind of go into later. So they use quite a bit of the landscape. So in 2019, we decided really to concentrate on trapping for spotted turtles, and we really expanded in 2020. And we wanted to see the movement patterns and population size. And so that was our goal. And here we could see a green frog on top of a turtle trap, which sometimes you find the frogs just staring at you. And so we did an extensive trapping survey at a couple of regional sites. And you could see visually, these are hook traps. They're expandable traps, and they kind of have a funnel on either end where we'll bait the traps with oily sardines. You just punch holes in the sardine can, put it in, and the turtles go into the trap, into like this funnel, and then they have a hard time getting out. They can get out, but they usually don't figure it out. So we set traps, as you can see in the lower left. They're checked daily. They're staked in the substrate and submerged halfway in water because the turtles are air breathing. So we want to make sure that the trap part of it's above water. More recently, we've inserted a pool noodle that's inserted in the trap or attached to it to keep it afloat, especially if you have a flooding event. We don't want the traps to get submerged. So it keeps the trap afloat no matter what the water conditions are. As mentioned, sardines as bait. And then coordinates are taken and ID tags are attached to the traps, and locations vary depending on the habitat. So for spotted turtle, we set traps in shallower water. And this is one of our former interns, and she was at one of the another state park. And as you can see, she caught something like 10 different spotted turtles at this one wetland. But that's typical ideal habitat for them. So we continue on. So if we do catch a turtle in a trap, they're weighed, they're measured, and they're processed. There's a whole processing that's involved with it. And in this picture, we also caught Blanding's turtle at another state park, along with spotted turtles. And then we have the question, how do we ID a turtle? Well, first we have to figure out, is it a male or female? So here we have a male, and you can kind of see that the shell, the plastron, the bottom shell it's called, is sort of convex, or concave rather. So it's sort of divots in. And then it's hard to see, but the cloacal opening is right there. And if that extends beyond the shell, then it's a male. And then this is a female. The shell is very flat, the bottom shell or plastron. The top shell is called the carapace. So it's very flat. And the cloacal opening doesn't go stretch beyond the edge of the shell. So her cloaca is kind of more inside. And that's so the male can mount the female easy. However, painted turtles, you can only distinguish by looking at the cloacal opening. Both males and females have flat shells. But with box turtles, spotted turtles, Blanding's turtles, wood turtles, all the males have that kind of concave bottom shell. And then we have something called annuli. And annuli are just like kind of trees, rings on a tree when you're counting tree rings. So as the turtle grows, with each year's worth of growth, there's actually a line that develops. So it is hard to see in the slide, but you can see sort of this is year 1 after it hatched. And that's year 2, year 3, 4, 5, 6. And then when you get in the middle, it's probably 7. So we estimated this juvenile to be about 7 years old. However, as the turtle ages, especially as they reach maturity, getting towards the teenage years in spotted turtles, their annuli get closer and closer together. So by the time they reach 15-ish or so, it becomes almost impossible to clearly see the annuli because the growth rates are greatly diminished. And then on top of that, you have shell wear. So these two adults are probably well into their probably 30 plus, I guess, maybe. They're pretty well along in years. And then the third thing we do is we notch each turtle. So you kind of see these little marks on the edge, and these are the edge scutes are called marginal scutes. So there's a whole numbering system, not to get too complicated, but each scute has a number, corresponding number. So if you put a notch in here and a notch here, you add it up, it's a 30 and 40, so 70. So this is turtle number 70. But each notch has a number. So new turtles we catch, we notch, and then the notch stays on the turtle through its whole life. If it's a young turtle, the notches will grow in over time, but with older turtles, they stay on for the life of the turtle. So you can catch a turtle 50 years later and you'll still see the notches. Okay. So every capture point, data is taken, such as we talked about, ID information, so it's sex, notch number. Many of our turtles, especially ones that we track, we pit tag. So it's just like a microchip you'd put in a dog. Same idea. And if they're carrying a transmitter, we put that information in. GPS points, the site name, maybe name of the pool it's in. Habitat information, we look at the canopy cover within a meter. We look at the dominant vegetation that's growing around the turtle where we find it. We look at the water depth, the water temperature. So we take all this information down. Behavior information, is it nesting? Is it kind of formed in underneath the leaf litter? Is it moving? Is it actively swimming? And any abnormal physical features. Sometimes we find turtles with maybe some kind of shell deformity or missing foot or something else. So we note that. So our goal was to find a new adult female, and if we did find one, it was captured, and then we put a radio transmitter to track the female's movement, habitat use, nest locations, using an antenna and a receiver. So the reason we were focusing on females is so we could find nest, and then I'll protect the nest, and then take the hatchlings for head starting at schools, the zoo, the aquarium, as we'll talk about later. So although we do also cost, these things are very expensive. So due to time to find them, even with radio tracking, it could take a considerable amount of time. And then with the cost of the radios, let me go back. Although we'd love to track more turtles, especially males, oftentimes it's just time and financially prohibitive to do that. But it's not to say we wouldn't get valuable information from males as well. But this gives you an idea. These are small transmitters that would be put on a spotted turtle. This is the maximum size of a transmitter. And this transmitter lasts about a year. So it sends out a beeping signal. So we have our director of education, he's doing radio telemetry, and you can see the box he's holding, and you just turn into the frequency of that radio, and then you point the antenna and you look and see where you can find the beeping noise, and then you can walk towards where it's beeping, and after a lot of searching, you'll eventually find the turtle. Very similar to what you see on TV when people track wolves or elk or bears or whatever, some large animal. Although I could tell you these guys are probably harder to find. So one of the things we're interested in is the habitat use of spotted turtles. And so it's, again, we're finding they use quite a bit of habitat, and we track them year round. So being that it's middle of winter, we thought we'd start with winter hibernation because this is exactly what they're doing right now. So this turtle here, call it number 32. We do number our turtles. It always comes up the idea of names, which is good too, but sometimes you associate a turtle when you're tracking it year after year. When you say that number, automatically you think of different personality traits. But anyway, this is number 32, and you can see this is a close-up of her. The ice had just frozen up enough to be able to walk on, and it was clear ice. There is no, which is kind of rare around here to get this kind of ice conditions. So we were able to take some amazing photos of these turtles under the ice. And this is another one here, number 55, and a third turtle here. And all these turtles we've tracked for 3 years or more. Okay, this is just a little video showing one of our turtles. And they actually can move under the ice and be active. So it's pretty remarkable to see them moving under the ice when the water's 33 degrees. So there we go. So yeah, that's pretty amazing to see that. Of course, their activity level is drastically reduced. It's just very periodically they'll move about in their little area. But come spring, as the water warms up, they'll come out to bask. And they're often very early to come out to bask, often in the first warm days in March. One year we had temperatures in the 70s, and they were basking on February 21st. Then it got cold and snowy in March, and they went back down underwater for a while. But yeah, spring is very important. It's a time where they really are doing a lot of feeding. A lot of food is available. We have fairy shrimp, wood frog tadpoles, lower left, and then spotted salamander eggs here on the right. And this provides a tremendous amount of food source for them to get through the year, especially there'd be less food when these pools dry up in the summer. I know that they are eating some, I'm sure, bugs and things in the forest. This is the time when food is definitely most plentiful. And they do use vernal pools, which is pretty unique. So as the pools dry up, it was interesting to note this past year, the pools did not dry up because we had so much rain, and the turtles did not move into upland areas. They stayed in their pools. They only traveled upland to go to the nesting areas, but they just stayed in their wetlands after that. Whereas in previous years, when the pools normally dry up, we'll find them in upland habitats like this on the left. This is leaf litter, white pine, oak forest. And they'll typically go upland and just stay in these cool forested areas. And another area where there's tons of canary grass, they'll just kind of hunker down. You can see, if you just put your hand underneath the grass, you'll feel it's nice and cool and moist. And they'll just spend a lot of their summer in these types of areas. So this turtle here in the canary grass is one up close. All right. And then in the fall, they go back to their hibernaculum. So they show a lot of what they call site fidelity. So they go back generally to the same areas to hibernate or to nest or to feed. This was kind of a special occasion. This turtle here, you can see a transmitter that's attached to her. So we were tracking this turtle, and I reached down underneath a shrub, a button bush, and picked up a turtle that had no radio. And that does happen in the fall or early spring. Sometimes you'll find males and females together, and you'll pick up a turtle, you think it's the turtle you're tracking, and it turns out to be another turtle. And usually it's a male. Not always, but oftentimes. And then I reached down, grabbed another turtle without a radio, and then another one. And then finally I got her. And then I reached around just checking, and then got this juvenile here, got another turtle. And after this photo was taken, I just double checked this little hole that was underneath the button bush and found a young juvenile as well. So there's 7 turtles all within a foot of each other. And so they kind of congregate oftentimes in these hibernaculums. It was very, very interesting. Another photo, I didn't get a chance to insert it, but we actually had 3 turtles that hibernated in Phragmites. There's a Phragmites patch near one of these wetlands, and they actually, we think of Phragmites as being all bad, but they are actually using the Phragmites, just like the canary grass being it's an invasive species, but they still utilized these invasive species as part of their microhabitat. And so we find 3 turtles in the same patch of Phragmites, 3 years in a row. The year they didn't hibernate there was the year we had the drought. So going back to our females, what we did at one of our sites is we took 7 females that we were able to rate, that had radios. We tracked them. We brought them to the Zoo New England's hospital right at Franklin Park. And our veterinary technicians did radiographs in each of the turtles. And 5 of the 7 had eggs. So you can see this beautifully illustrated here. This turtle here on the left, number 55. And we found her eggs in 2020. And then this one here, 64. We didn't find her eggs, but we did find another female with 3 eggs. So the reason we took them for radiograph, first, it helps us to know how many eggs they have for our research, but also it tells us which turtles we really need to focus on as far as trying to find their nest. So the 2 that didn't have eggs, we didn't have to worry about trying to track them to look for their nest. And so what we did is, it's very, very tricky to track spotted turtles to their nesting areas. They're unlike some turtles where, like blandings, they'll go up for a night or 2 or a couple days, find a nest spot, go back to the water. These guys we find will travel several days over land to other wetlands. We think one may not even have left the wetland. It may have nested in the wetland. It lives in year round. But what we did know, we talked to some other researchers, and they said if you know any major movements, try to put a thread bobbin on it. So it was the Orient Society out of Georgia did that. So we tried to emulate what they did. And so we put this thread bobbin, it's very tiny, very thin thread. In this middle turtle here, we did actually find her nest using the thread bobbin method. And what it does is when you find a turtle, we weigh it, we attach the thread to, let's say, a shrub or something. And as the turtle walks to its destination, you come in the next day and you just follow the thread to see where the turtle went. It gives you an exact path of where the turtle goes. And if the string looks like it's really bunched up, it goes into the soil, you check that area, and if you find eggs, you've gotten success. They do travel. It's neat to see where they actually go. With radio telemetry, you're just finding them at that one spot, but with the thread, you see where they walked. We had one turtle go underneath the culvert on one side and then come out the other side. Instead of going across the path, she decided to go a long way to get to this culvert and go to the other side. So that turtle that the middle turtle we just saw, she nested in this huge wood chip pile. This landowner actually lives right by the park here, and she had come out of a vernal pool about third of a mile away. She literally, when we followed the string, it was going back and forth through this mound of mulch, which radiates a lot of heat. That's probably why she nested here. And so she climbed up, and we found her string. It was inside the wood chips here. It was kind of bunched up a little bit. And sure enough, about an inch below the surface, we found 4 eggs. So we put a screen on it. Just the landowner was great. He was agreeable to us, leaving the wood pile there and having us protect the eggs. So we put a screen there and left it in place to keep it protected from raccoons and skunks. And then we had another turtle which decided to nest on this mountain bike trail. If you see this little stick here, it was right below that stick, and she laid 3 eggs. We noticed the dirt was kind of patted down, and so we checked again about an inch below the surface. There's 3 eggs. So this is a bad spot because it's a hiking trail, mountain bike trail. So if the nest can't be protected, we can't put a mesh around it, then we'll find another site to move the eggs to a safe location. And that's what we did here. We went to another nice open sunny spot, and we were able to dig a hole just a couple inches below, put mesh over it, and then have it protected. And then on day 50, and we pulled and incubated the eggs until hatching, which would be another 2 to 3 weeks later. So we left them in and pulled at day 50 to allow natural incubation to take effect. Usually sex determination occurs in the second trimester of the incubation period. So it's past that period. And it's also getting to time period when they get close to hatching. So we're unable to check the nest every single day and to put a nest enclosure, like a cage. So we do that to make sure we are able to catch all the hatchlings. And then this is a completely different habitat that spotted turtles will utilize as well. It's, again, a typical kind of vernal pool, sphagnum-y, tussock sedge area. And it's remarkably warm underneath this moss. You kind of can feel its warmth really radiates in here. And so we do the same thing. We'll put the mesh on, and about 50 days later, pull the eggs for the incubation. So they have the ability to do that. Unlike most turtles, which you strictly use uplands and dry, open, sunny areas with loose soil, these guys can utilize this mossy area as well. And then new hatchlings. So this is exciting. We had these 2 turtles on the right came from the turtle that you saw the x-ray on with the 4 eggs. So they're being all 4 are being head started. These 6 turtles were hatched this past early September, around the 1st of September. These guys were hatched. So these guys are at schools, and go into that a little bit, but that was really exciting to find these nests. So head starting, the goal of head starting is to raise the turtles in a nice warm environment, to make them grow faster, and then release them at a larger size. And that enables them to survive better. Hatchlings are very fragile. They're easy prey for a number of different animals. They also are very susceptible to environmental changes, so they can dry out if they're in areas where it's too hot and sunny, or they could freeze if they don't get below the frost line, and they're just very fragile. So when we release turtles that are larger, that are more like a 5-year-old or bigger turtle, they have a greater chance of survivorship. So spotted turtles we raise indoors, and we're just starting out with schools this year, a couple of schools. But we raise them for 20 months because they are smaller, so it takes longer for them to grow to a good size. Our blandings and wood turtles are raised for 9 months, so the schools get their hatchlings usually September, October, and then they release them in June. And they naturally grow faster into a larger size, so they don't need to be kept as long for head starting. And then this is just a typical school setup for blandings turtles. Spotted turtles would be in pretty much an identical setup. So we can see, and we want to take a note of this little turtle here. It's a fairly young hatchling that the student has. And then this is the turtle at release 9 months later. So you can see a huge size difference. This is about the size of a 5-year-old blandings turtle had it not been head started, if it was just a wild caught blandings turtle. So a significantly larger size. And you can see a radio is being attached to this turtle so that we can monitor it and see its survivorship. Oftentimes we've done this for 2 to 3 years post-release. And overall, I've had very good success with many of our blandings turtles. We haven't done it with spotted turtles yet. This will be our first spring doing that. So it's going to be a brand new thing for us. So again, we find that juveniles will use different habitats, especially in the summer months. They might move differently, and these are all things that we want to try to find out. And some success, again, with our blandings head starts. This turtle on the left was head started or hatched in 2007, released in 2008. This one was hatched in 2009 and released in 2010. And we caught both of these turtles in 2019. The turtle on the left we tracked until 2021. So yeah, so these two, you could see that they're practically, especially the one on the left, practically adult size, really. So the next thing we hope to see with blandings turtles is to see if they actually nest. If we get any head starts that nest, that would be super exciting. So we're hoping that in the next few years. Okay, so some of the threats that our spotted turtles and other turtles deal with. Mammal predators. So even though they're a larger size when they get released for the head starts, and then spotted turtles, they're just small, period. Even when we release them after head starting, they're going to be close to adult size, but there's still threats they have to deal with. First, the threat is egg predation. That's huge. A lot of your raccoons, skunks, foxes, and so forth love turtle eggs, so they often get decimated. And then another issue is, again, because if they're so small, the turtles don't pull themselves inside their shell, and let's say a mink, a raccoon comes along, they can bite off a toe or a foot. So we do have turtles that we've caught or that have a missing foot. This one lost a couple toes and had a missing foot on the other side. Still got around quite well, but still it is a threat. And this turtle particularly, when you looked at its shell, you could see something was chewing on it at some point from an old injury. Then we've caught, in one site, we caught a number of spotted turtles with these gashes. We have no idea. These are very old injuries. We have no idea where this came from. We're guessing some kind of maybe mowing went on. Maybe they were near a grassy area, got mowed. Probably if they were hit by a car, it would have been a lot worse than this. But that's one of the things. It's a big issue in certain areas with wood turtles and agricultural areas. Unfortunately, this dead blandings turtle on the lower left was killed crossing a street. The one good thing I have to say with our spotted turtles that we've been tracking, they've never crossed a road. So they've all been contained, very busy roads surrounding their habitat in the park systems that they're in, but we've never actually tracked them crossing a road, which is very good. And so they seem to have a mental map of knowing where to go. And then, excuse me, initiatives, something we like to work, we are currently working with. One of our places, our research sites is with DCR, is doing some nest creation. One site we're looking at Blandings turtles. And this place here is on the left is in Groton, or not Groton, Georgetown, Mass, for a Blandings turtle mitigation project. So something for spotted turtles wouldn't need to be this extensive, but this would be a nice turtle nesting area. And then invasive species control. So again, certain areas, there's huge expanses of Phragmites, which, again, as mentioned, the turtles do use Phragmites, but they use areas where the Phragmites is not in huge stands. It's like patches or smaller stands of Phragmites nearby other native plants and so forth. So they do utilize it. So it's a matter of keeping the Phragmites from overtaking areas that are not presently overtaken by Phragmites. And so that would be something to watch. It would be impossible to get rid of it, but to just sort of keep it at bay. And then what could we do? So we can, this turtle on the left crosses a commonly used trail. And I have had people come up to me and say, oh, I just saw a turtle crossing a trail. So possibly you might see one cross a trail if you're near a wetland. So we can report any sightings and send a photo to Zoo New England, our field conservation department. That's the email. I don't know if you might want to put it in the chat, but so you could feel free to email us. If you take a photograph looking down on the turtle without picking it up, we might be able to read notches if it was a turtle that we had notched. We could use the iNaturalist app to document a sighting. So iNaturalist is a great tool, and now the state's looking at iNaturalist to looking at all the reptile amphibian sightings, and they have a way of obscuring it, so you don't have to worry about trying to hide the information of the location. So there's a way that the iNaturalist can do that, and the state can do that. It's a little more work if we do it ourselves, but we could report and send a photo to the Mass Natural Heritage Endangered Species Program on their Heritage Hub. It's an online tool that you can enter rare species reports. But it's a little more work. You could certainly send the information to us, and then we could submit it to them. And then just a note to safely move a turtle crossing the road toward the direction it was moving to. And this, we most often see turtles crossing the road between May and July, late May to early July, during nesting season. So being a very busy area with roads, we want to do it safely. And so, just want to keep that in mind as well. And there's some online things too, as far as how to move a turtle, especially a snapping turtle, because that can be a little tricky. So just to want to make acknowledgements. Obviously, the Friends of the Blue Hills have been gracious in letting us do this presentation. And I always want to thank the Mass Natural Heritage Endangered Species Program, Department of Conservation and Recreation, been really supportive. Fuller Foundation allowed us to hire a seasonal technician last year to help with the spotted turtle work, and of course the Neponset River Watershed Association. So anyways, it's kind of the rundown. Are there any questions? Or Brian, feel free to jump in if you had thoughts as well.
Thank you so much for that presentation. Awesome job to both of you. If there are any questions that aren't already put in the chat, if you want to just type them and put them in the chat, I can go ahead and read through those. And if you want to ask a question yourself, just please use the raise hand feature, which you can see if you click the reactions at the bottom menu of your screen. So let's start looking through some of these questions because I was seeing some great questions roll in. So one of the first questions is, how do the spotted turtles breathe under the ice in the winter while they're hibernating?
Oh, good question. I meant to bring that out. So they can actually exchange, and Brian probably give you a better idea, but they can exchange oxygen through their cloaca or their rear end, and also through the lining of their mouth, so they can, absorb oxygen through there. And they often may use areas that have, we notice a lot of turtles hibernate underneath root masses, or maybe near water. It might not look to us flowing, but maybe circulating in some way through root masses or through, we have one site where the turtles go underneath little rock boulder fields, so to speak, or little boulders. And so there's it's one way they can do that. Also, their blood doesn't become acidic because they'll use the calcium in their bones to help keep their blood values level, so they don't become acidic that way. So yeah, that's feel free to jump in, Brian, if you
No, that's great, John. It was a really cool experiment that a physiologist did with painted turtles. It was not sure it would be approvable nowadays, but he took 3 painted turtles and he put them in a small enclosure that was chilled down to just above freezing. And he bubbled liquid nitrogen into this enclosure that had a top and a one-way valve on. So it drove out all the oxygen in the water, closed the valve, closed the top, left the turtles in for 3 months. So in water where they couldn't surface, couldn't breathe, and there's absolutely no oxygen in the water, and the turtles were fine. So turtles in under the ice slow their metabolism down tremendously. Painted turtles and likely spotted turtles maybe have a heart rate that's about once every 5 minutes or so, 1 beat every 5 minutes or so. There's just a teeny bit of electrical activity in their brains. They can, as John was showing, if they need to, they can kind of revive themselves and move around a bit, but generally they're just chilling under the ice and consuming almost no oxygen, and they can get by with none at all. So really a remarkable adaptation.
Yeah, that is such amazing resiliency. Well, thank you for your explanations. That definitely totally covers it. We have another question from Emma saying, we kayak around the Charles around Newton, Nahantun in the summer and see a lot of sunbathing turtles. Do you know what variety those may be?
Good question. I wish I knew that site. I don't know that site myself. I've heard of it, but it's hard to say. It could either be painted turtles. Painted turtles are often what people call sun turtles because they are so abundant, and they'll oftentimes bask in a line of, like, there's a log, you'll see a whole line of painted turtles basking. Spotted turtles will do similar. They do bask. I haven't seen as many as far as like a whole line of them, but I have seen them bask on a log. So it's certainly possible it could be spotted turtles. They do live in similar habitats, so it could be either one. Hard to tell because sometimes looking far away, spotted turtles are a little smaller than painted turtles, but there's a lot of size overlap. Unless you have sometimes maybe little binoculars or something and clearly see yellow spots, it could be hard to tell.
Yeah, no, awesome. I would say maybe it'd be fun next time you go kayaking to bring a little pair of binoculars and see if you can find any details, Emma. And then one final question just from me. Oh, there's another one. I'll do the one that I have written down, which is you mentioned when you were numbering the turtles that you started to associate traits with them and habits. And I was wondering if you had a favorite or one that would do the same thing over and over again that stands out to you.
Yeah, so a couple, it's funny, they, as I kind of briefly mentioned, they have strong site fidelity, so they will often go to the same pool to hibernate, the same place to go to their spring feeding area or their nesting area. And I think one turtle that's kind of amazes me is number 55. We actually are head starting 4 of her offspring that we're going to release this spring. But she literally traveled half a mile straight line from her spring feeding area to her nesting area. And that's just a straight line. She obviously did a little bit of zigzagging. But even when we were following her string, she knew like where she was going. It took her 2 days to get there. And then she spent 3 days in this other wetland, laid her eggs. Then the next morning we came in, we saw she had lost a lot of weight and followed the string back. String had broken, but fortunately the other half of the string was still there. So we actually found her eggs. And again, the day after she was on land, the next morning, then the following day, she was back at her spring wetland. Then she goes to this other site to hibernate, which is again another half a mile. So they have this mental map, and that she's the long distance traveler. I have others that don't seem to move very much at all, just stay in the same, very close. And then we have ones that are in between. They travel a bit, but they're not as far as she is. But it's really remarkable how and how they get that, I don't know. So.
Awesome. Thank you so much. And kind of relating to that, another question, how many miles per hour does a turtle walk? If you know that off the top of your head.
Ooh, I don't. I could say it's steady. It's faster than we would expect. I don't know how, I can't say, but again, just that one turtle that we tracked, she tracked a half a mile. I think she wasn't traveling half a mile all at once. She rested for many hours in between, but it took her 2 days. It was 2 days there, 2 days back. But yeah, it's a good question. I don't know if you know, Brian.
It's definitely not in the miles per hour, at least not over the long haul. Blanding turtles, which are much larger, can move a little bit faster. They've got longer legs. We see them often traveling upwards of half a mile to their nesting site, but that kind of distance takes them at least several hours to cover. So they're not setting any speed record.
Thank you. That makes a lot of sense. Yeah, slow movers, but they get where they're going. So, here's another question: how is climate change impacting the turtle population?
Yeah, it's hard to say. I think, Brian, you can jump in, but I think what we're seeing is the drastic precipitation changes. Going from drought to flooding condition, and that can affect also our egg development. If it's too wet or if it's too dry. We think one of our nests, the one that I showed you on the mulch pile, didn't make it, perhaps because it was too wet and the wood chip pile would naturally hold in moisture. So it may have just, the eggs were kind of moldy when we checked them on day 50. So that seems to be an issue. I don't think with this species, spotted turtles are more of a southern species, so that's probably not an issue as far as like warmer winters. But I think it's the precipitation changes and perhaps the nesting behavior or the egg development that might be affected by that. I don't know if Brian has thoughts. So.
Yeah, it's complicated, like John said. There's no simple answer. And, one of the consequences of our climate change is not just kind of an overall increase in average temperature, which is a consequence, but also increased variability and volatility and precipitation, how we get the precipitation and stuff like that. So those all have potential consequences. They're not all negative. As John mentioned, we're near the northern edge of spotted turtle range. The spotted turtles have historically been limited from going much further in New England, largely because the cold temperatures that set in the fall prevent spotted turtle babies from hatching successfully in nests that are too far north. So if all things were equal and if there were not big roads in the way, then likely species like spotted turtles would extend their range over time further north into Maine, for example. But of course, all things are not equal, and there are a lot of big roads, so that's not always possible. Also, spotted turtles, like John kind of alluded to, have what's called temperature-dependent sex determination. So when a spotted turtle mom lays her eggs, those eggs at that point are neither boys nor girls. Each egg, the sex is not determined by, or not primarily determined by anything the embryo inherits from mom or dad. It's determined by the temperature that the egg is exposed to in about the middle 3 weeks of its development. Around here, that's usually much of July. And so if the temperatures in July are really warm, then that egg will normally turn into a female. If the temperatures are relatively cool, it'll normally turn into a male. So we always tell the kids we work with, you can remember it if you just remember hot chicks and cool dudes. Sort of works for a lot of our turtles over here, not for all. And clearly climate change could affect that, right? So warming climates could wind up with populations that become increasingly female biased. We've been looking at that for a long time now in Blanding's turtles. Unfortunately, we don't see any real signal of that happening. The turtles are able to vary the sites that they nest in, and whether they put their nests in more or less shady areas can easily affect the temperature much more than the amount of climate change, say, that's happened over the past century. So it's complicated. Good question.
Yeah, no, it definitely seems very complicated, but what an interesting and complex answer as well. Thank you so much again for sharing your research and your insights and knowledge. We're very grateful. And just as one last reminder, we hope to see you again at the next research presentation on the Blue Hills at February 17th. We got all the way through the questions.